Okay, so today I'm going to be going over a side angle problem. And in this case, it is going to be a two solution case, which means it is going to have two triangles. So to solve the two triangle case, we're going to be using the law of cosines. This right here is the equation we are using, so it is best to memorize it. So this is just a little example of what we're going to be doing. As you can see, this equation is eventually split into these two triangles with different angles. This is how we're going to break it up. So first we're going to have side A right here, which is obviously 58. And then we're going to have B right here, and then C right here. And then everything is opposite of each other. So this is going to be side B down here. And this is side A right here. And then this is going to be side C right here. So obviously side A is 11.4, which this is where we're getting the information from, is right here, obviously. So then B is going to be 12.8. And then what we're going to do after, since we're solving for two triangles, is we're going to break it right down the middle like this and label this part H right here. And then using the law of sines, we're going to be solving for this right now. And we're eventually going to find H from that. So first we're going to start off, it's going to be what we're given. We're going to use what we're given. So obviously it is sine 58 equals H, which then we're going to be using B. So it's going to be 12.8. Then you're going to do some cross multiplying. So it's going to be H equals 12.8 times sine 58. And if you plug that into your calculator, it is going to eventually equal 10.86. So now that we have our H, which is obviously 10.86, we are trying to use this to solve that, to prove that we have two triangles right here. So in that case, we are going to be using the equation height is less than side opposite angle, which in this case will be 11.4 because we have A right here. So the opposite would be A. So it's 11.4. And then is less than B. So we can figure this out right now and prove this, that since we have height, which is now 10.86, that is less than our side opposite angle, which is 11.4, which is then less than our B, which is 12.8. So since this is true, we know that now we have two triangles, and we can now solve for the other triangle. Okay, so now that we know that we can finally have two triangles, we are going to be solving for all the missing angles and sides that we have. So first, what I like to do is, starting with the first triangle, we're going to solve for angle B. So what I like to do is I like to kind of organize everything into this little chart. So we know that we have obviously angle A, which is 58, and we don't have angle B, which we're going to solve in a minute, and then we don't have angle C. We do, however, have side A, which is 11.4, and we have side B, which is 12.8, and then we don't have side C. So how we're going to solve this is we're going to use the law of sines again. So it's going to be sine A over A equals sine B over B. So it's going to be sine 58 over 11.4 equals sine B over 12.8. So to solve for sine B, you're going to need to multiply 12.8 on both sides. So we're going to multiply here, and we're going to multiply here. So that would equal sine B equals 12.8 times sine 58 over 11.4. And once you plug it in the calculator, you will find your answer for side. Plug it in the calculator, you should get sine B equals 0.95219. And if you get anything greater than 1, you plugged it in wrong and you're going to need to recheck your calculations or make sure your calculator is in the right degree or right setting. Make sure it's in degrees, because otherwise you could get the wrong calculation and your whole measurements will be messed up. So once we get to that, you can't just leave it like that. So we're going to have to use sine inverse, and then you're going to multiply your number that you got. And then once you plug that in, you can finally get your angle, which is going to be 72.212 degrees, or if you want to round it, you can get 72.2 degrees. So now that we have that, I like to fill it in a different color, just so I don't get confused and like I know what I found and I know how to go back to check my work. So you'll put in right here 72.2 degrees. So now that we have these two angles, we can actually solve for C right now. So what you're going to do is, since all angles of a triangle add up to 180, all you have to do, I'm going to use a different color to show you, is you're going to subtract 180 minus 58 minus 72.2. And when you subtract these, you will eventually get 49.8 degrees. So now you can fill that in right here, 49.8 degrees. So now with this information, you can actually solve for the other side. So now we can solve for this one right here. So now you do the exact same thing, basically. And now you just, instead of solving for sine and over B, you're just going to solve for the C's. So I'll show you how to set that up. Okay, so obviously for side C, you're going to use the same equation, but now, since you have both signs, you're going to switch it around a little bit. So it's going to be 11.4 multiplying on both sides now. So eventually you're going to get sine 49.8 over sine 58. So when you multiply all those all together, you should get 10.27, which I will add up here, 10.27. So this, now we have completed one triangle. So this will be triangle number 1 that we have solved. All of this right here. So now next I'm going to show you how to solve for triangle number 2. Okay, so I took the liberty of already starting to fill up the chart again, once again. So we're going to take everything that we know from our first equation again and plug it into right here. And so now we're going to solve for angle B for the second triangle. So what you're going to do is you're going to start with 180, since once again all three angles of a triangle equal 180. And you're going to use the 72.2, which you got from this first B right here, and you're going to subtract it, minus 72.2. So the reason why we're doing that is because since this whole angle right here equals 72.2, we're trying to solve now for the other part of B, which will be, so let me plug it in. So 180 minus 72.2, which will be 107.8. So now that we know that, 107.8, and then now once again we can solve for this one right here. So C2 will equal 180 minus 107.8 minus 58, which will equal 14.2. So once again, now that we know all of these angles, now we can solve for C. So I'm just going to write how we found that down here. So what we're going to do is we're going to do multiplying 11.4 by both sides once again. So it was going to equal 11.4 times sine 14.2 over sine 58, which will equal 3.3. So now that we have both triangles, this is how you solve a two triangle side-side angle equation. Now we're going to be solving for this chart right here. So to dive right in, basically we're going to be using now the law of cosines for this one, which is different than our previous problem because that was law of sines. So cosines is a little bit different. To solve for cosines, you're going to use this equation right here, and it's different variables than these ones right here, but I find it easier to use this when I'm forming my equation. So I'll just substitute these numbers in for these ones, and it will make sense. So basically, first we're going to start off by figuring out the side lengths for these ones right here. So we're going to start with D. D is going to be 9. So whatever one you're solving for in this box, you're going to be putting right here. So first I'm just going to show you guys how to do 9, and you guys will have to figure out how to do 10 through 16 on your own. And I'll come back and show you like the answers. So for right now, I'm just going to put this for 9 so we're not confused and we know we're trying to solve like this is 9. So to solve for this one's kind of already given to us. It's kind of showing us how to set it up to solve this one right here, because this one we're only giving one value. So for this length right here, we're going to add basically these two lengths together. So that means this will be 10 inches right here. This length right here will be 10 inches. So then to solve for this one, the radius is right here of the circle, and we know that this is showing the radius right here as well because it goes all around the circle. And it's showing us that the radius is actually 4. So we can say right here that, oh, sorry, it's kind of hard to see, but right here is 4 inches because, once again, the radius is 4 and it's the same all around the circle. So when you add these together, it equals 7 inches. So now that we know all of our values, we're going to plug it into this equation right here, which I will show you how. So since we don't really have cosine A, we're going to be putting that as cosine theta. Actually, I'm going to do it in a different color so it's easier for us to follow along. So it's going to be cosine theta equals b squared. So I'm going to use my b squared as the 10. So it's going to be 10 squared plus 7 squared minus 9 squared over 2, 10, and 7. So when you add all of these up, you will get, okay, so when you multiply, I'm going to move this down a little bit more. So when you multiply all of these together and divide them, you should get cosine theta equals 0.486. So to solve for an angle, we learned in the previous one, we're going to have to use cosine inverse, which is cosine -1. And then you're going to use the same decimal you got, 4.86, which will eventually equal 60.94 or 60.9. So then we're going to plug this number in right up here. So this will be 60.9. Now, to solve for side, we need to use the arc length. So basically, we're going to plug in our 360 minus, so our angle, so it's going to be 60.9. And then we're going to divide that by 360, and we're going to multiply it by 2 pi r, which our radius, as we know it, is 4. So we're going to plug that in right there, pi 4. Okay, so once you subtract these, you are going to get, oh, this should be S, by the way. You're going to get S equals 299.06 divided by 360 times 2 pi 4, which will equal 20.88 inches, or if you round it, it should be 20.9 inches. So we're going to plug this right here. So it should equal 20.9. Now to solve for the rest of the graph, or the chart, you're going to use the exact same steps of the law of cosine and the arc length to solve for the rest. And I will show you guys how to solve them right now. Okay, so now I've went back and color-coded everything so you can see my work. So I used the same equation I did here to solve for the degrees, and then I used the arc length to solve for here. And these are all the answers you should get. And if you didn't get these, I would check the right calculations to make sure you added and subtracted right, you multiplied right, and to make sure you plugged in like the cosines right. But yeah, that is how you solve 45, and thank you for watching.